Okay, so welcome, and today we're going to start talking about measurements, okay? And we're going to be talking about everything that falls into that category of dealing with measurements. We're going to talk about units and significant digits today, and we're going to get into some other things too. The English or SI system, the standard English system, the metric system. We're going to discuss those, how to conversions, things like that. So, but we're going to start with the idea of units. So again, a number is just a number, but if a number is applied to units, then we often, that's what we call a measured value or a measured number. Okay, so anytime we measure something, there's going to be units involved, right? There's going to be a context involved. Okay, and so we always want to use those units when we're talking to people, when we're writing, when we're doing our calculations. We always want to make sure that we include units. Units are very important. If you're doing let's say a test or something like that, if it's an online test, then you may not need the units, but read carefully. They may already have the units involved. But if you're taking a paper test, then I would say, hey, if there's a context, if it's a word problem that's involved and the units are involved, then your answer should always have units because there's a context involved, right? It's not like you're saying, what's 2 plus 3, right? But in a word problem, you might be asking, hey, if I'm measuring this many feet of length, and I'm measuring this many feet of length, and I want to know, okay, well, how much area of carpeting do I need, right? Let's say I'm measuring for carpeting, or let's say I'm adding the feet. If I want to know what total linear feet I have, right? You're going to be adding, so your answer is going to be in feet, or your answer is going to be in square feet if you're talking about area, things like that. Okay, so now the way to understand this is just real simple, is the units tell us what the measurement is. So in other words, when we say 8 feet, what we mean is that we've got 8 times the typical standard measurement for a foot, right? So we could write this as 8 times 1 foot, right? So that's the way we can understand units. It gives us this idea. So again, 8 is different, right? If I have 8, it's just a number. But if I put units on there, then I've got a context. 8 feet is different than 8 pounds, right? 8 feet is a measurement of distance, right? It's a length. 8 pounds would be a measurement of force or weight, and so on. If I say 8 milliliters, then I'm talking about volume, right? So again, make sure you understand that. The other thing too is significant digits. So now I wrote this down, and again, copy it, memorize it, know it, okay? So this comes up more in the technical fields, right? If you're in like the trades, let's say plumbing or carpenter or something like that, most of the trades, they have their own way of dealing with measurement accuracy, right? In any measurement, when you're involved dealing with people doing the measuring or instruments, right? Both of those, there's uncertainty that's built into that, right? Every one of us measures differently, right? Instruments measure differently every time you use it, okay? So that being said, our measurements are not going to be like exact, right? There's always going to be this error, this uncertainty, okay? Now, in most of the trades and things like that where you have your own rules of how you deal with rounding and dealing with precision, but in more of the technical areas, more technical fields of engineering and things like that, they have their guidelines for significant digits, and these are the guidelines for determining the number of significant digits. Because again, if you're basing your measurements on if you're using measured values, measured numbers, right? So there's going to be uncertainty. So when you're dealing with calculations based on measured values, measured numbers, then we got to have some way of dealing with how are we going to round our answers, okay? How are we going to do that so that we get a certain amount of precision, okay? Now, how do we deal with significant digits? So specifically, for the rules of significant digits, this is again used in more technical fields, okay? And this is how it works. So we want to count the number of significant digits, and then we're going to want to make sure that our answers are based on the number of significant digits in some cases, okay, in particular cases. So first of all, how do we determine what significant digits are? Well, here are the rules, okay? So all non-zero digits in a number are significant. So those are ones you're going to want to count, okay? A zero is significant under these circumstances. So a zero is always significant if it falls between two significant digits. It will also be significant if it comes at the right end of a decimal number. What do I mean by that? Well, a decimal number is if I have 101.030, right? So if this is a measured number, let's say this is, I'm talking about millimeters, right? So let's say I've got a micrometer and I'm measuring the, well, that would be an awful big micrometer. But anyway, so let's say I'm measuring the outside diameter of a pipe. And so my micrometer reads out to the thousandths place, right? And so this is the measurement that I'm reading from my micrometer. So, this zero would be significant because it comes at the end, right? The right end of a decimal number. This is a decimal number, right? Has a decimal. So this zero is significant. This zero is significant because it's between two significant digits. And so is this one, right? Now also, a zero is significant if it's marked with an overbar. So it has an overbar in it, then you assume, then you know it's being counted as a significant digit, okay? Now, zero is not significant when it is at the right end of a whole number, okay? So if I have a whole number, let's say 32, or 320, let's say that's my measurement, right? This zero is not significant because it comes at the right end of a whole number. Also, zero is never significant if it's at the left end of any number. So if I put a zero at the beginning of this number, or if I put a zero at the beginning of this number, that does nothing for the number. Does not add accuracy or anything. So that zero is insignificant. It's not significant. So we don't need it. Okay? It doesn't do anything for our measurement as far as accuracy or precision. Okay? So again, make sure you understand these rules and make sure you apply them because that's going to become important later. It's not only being able to to know what significant digits are in a particular measurement number, but when we get into adding, subtracting, multiplying, and dividing numbers, right, measured numbers, then we're going to want to, in some of those cases, look at significant digits, and then we're going to have to apply rules as far as, okay, how many significant digits should my answer have? And so we're going to do some examples, and we'll talk more about that next time.